Let's do a hard one then. So one where we do not have a bijection, the one that you guys gave me answers in your reading assignment to. For example, let's say that x is the positive integers and y is the real numbers. In this case, the cardinality of x is not equal to the cardinality of y. They are not the same. Here's the reason that they are not the same, and this is called Cantor's diagonal argument. Cantor's diagonal argument. So we are going to assume that f going from x to y is a bijection, and we are going to find a contradiction. We can't say anything about f at all because I have to do this for all functions f, right? So we're assuming that I have a bijection and I need to find a contradiction. I can't assume anything about f at all. What I can do is make a chart. So let's make a chart here, or an arrow diagram. We'll do it this way. So 1, 2, 3. We're gonna send 1. I can't send this to something specific because I have to take a generic value f. So let's notate this as D10. That's the part before the decimal point. And then we're gonna do D11, D12, D13, and this is gonna keep going forever. For example, if we had f of 1 equaling, I don't know, 2.368, 524781, etc. Okay, then this would be D10 equals 2, D11 equals 3, D12 equals 6. We'll do one more. D13 equals 8, etc. So does that help you see the notation that I'm using over here? Does that notation that I'm using over here make sense now? I have a number, and if this stops, that's okay. We can just add zeros all the way out. So we can continue to add zeros, and then these will go forever because they are real numbers. Okay, does that notation help? This is my decimal point right here. So this is the number before the decimal point, and that's my number after the decimal point. Everybody okay with that? Making sense? Okay, so 2 is then gonna go to D20 is the number before the decimal point, and then D21, D22, D23, etc. So I've got my next one. I'm just changing notation. I don't know what this function is because I have to assume this works for all functions. And then one more, we'll do 3. 3 going to D30, D31, D32, D33, etc. Okay. Everybody good? All good? Okay, let's call these numbers also D1, D2, D3, etc. So my notation is f of x equals d sub x. That's my notation. And then here's how I've gotten my d numbers expanded. Give me a thumbs up telling me you're hanging with me up to this point in time. You see it? We're good? Yes, yes, yes. Okay, good. All right, so here's what we're gonna do. We are going to create a new number. And I'm gonna call it D. Do I really wanna call it D? Now let's call it Y. So Y, and Y is gonna equal Y0 dot Y1, Y2, Y3, etc. I'm gonna tell you how to create Y. Y0 is just going to be equal to 1. You can pick Y0 to be anything you want. It doesn't really make a difference. All right, and then Y1 is going to be equal to D11 plus 1, and then I'm going to put in mod 10. Have we talked about modular arithmetic in here? I don't remember. Yes, clock arithmetic. Grace is nodding at me. She's only ever had me for this class, so we must have. That's good to know. So basically what this means is that if D11 is equal to 9 and I add 1, I get 10, that doesn't work. So I got to go around the circle and say, go back to 0. Okay. So Y2 is going to equal D22 plus 1 mod 10, and then we can say et cetera. So here's why it's a diagonal argument. I'm looking at the first element here, the second decimal point here, the third decimal point here, et cetera. Okay, that's why it's going to be diagonal. Do we see that it's a diagonal argument? And what this tells me is that y sub I is not equal to d sub I, right? I'm adding 1. I'm not getting the same number here. I'm adding 1, so I am totally not getting the same number here. And that tells me that y is not equal to d sub I. It's not equal to d1 because it's different in the first point after the decimal point. Y and d1 are not the same. This first place after the decimal point is different. Y and d2 are not the same because the second place after the decimal point is different. Y and D3 are not the same because the third place after the decimal point is different. First place might be different, might not, I don't really care, that one doesn't make a difference. But each of these has a different number in each of the places after the decimal point. So Y is not equal to D sub I. Give me a thumbs up, tell me you see why Y is not equal to D sub I. We're good, we're seeing that changing after the decimal point, kinda, sorta, maybe. So again, I have y1 equals d1 plus 1, right? d1, 1 plus 1. So these two aren't the same. If I had an 8 here, I'm gonna have a 9 here. If I had a 4 here, I'm gonna have a 5 here, right? I'm adding 1. So this point and this point aren't the same. First number after the decimal point here and first number after the decimal point here are different. And that tells me this whole number here and this whole number here are different. Is that any better? Kind of, sort of, maybe, kind of. Okay, so what this tells me is that y, sorry, my board is getting messy, y is not in the right-hand column. Y is not in the right-hand column, right? The numbers that I have listed out in the right-hand column are all my D's, and I just said that Y isn't one of those D's, so Y is not in the right-hand column. Making sense that Y is not in the right-hand column? Okay, so that tells me that Y does not have a preimage. If Y is in the right-hand column, Y is not in the right-hand column, then there's nothing in the left-hand column that Y comes from, right? Y does not have a preimage. And therefore, F is not surjective. I found something that doesn't have a preimage, so F is not surjective. Do we see why F is not surjective? Y is not in the right-hand column. Y does not have a preimage, so F can't be surjective. Do I have a contradiction? Go back to the beginning of my proof. Do I have a contradiction? What did I assume? And why can I write my handy dandy contradiction symbol here? What did I assume that I have contradicted? Be brave, volunteer. You nodded at me. You see your contradiction. What did I assume? What do I got? Somebody, this is my last example for class. When we're done with this, we're done. So help me out. What did I assume that has a contradiction? You've had class with each other all semester. You can be brave and talk on Zoom. What do you got, Grace? Go ahead. Nope, you're muted. You muted yourself back. There you go.
I pressed it. It's not a bijection because it's not surjective.
Yes, this is F is not surjective, and the contradiction is we assumed F was a bijection. Okay, so therefore, we contradicted our original statement. Therefore, the cardinality of X is not equal to the cardinality of Y, or cardinality of the integers is not equal to the cardinality of the real numbers. So there are not as many integers as there are real numbers. But, and this leads into Wednesday, both of these sets have infinite cardinality, right? Both of these sets have infinite cardinality. So what that means is there have to be different sizes of infinity, because I have two sets that do not have the same cardinality, but that both are equal. I want you to think about this for just a minute. It's really, really cool. Two sets, both infinite, not the same cardinality. So therefore there are different infinite cardinalities, and that is what we are going to talk about on Wednesday. This is a hugely cool thing, especially in analysis, but in math in general. We're going to play a little bit more with the different types of infinite cardinalities. They fall into two types, and you'll read about those a little bit, and then we'll talk about it on Wednesday. It's really cool. If you're a mathematician, this is really cool. I'm not conveying how very cool this is because it doesn't come across as well on Zoom as it does in the classroom, but this is really cool that there are different sizes of infinity. Okay, questions? Anything before we finish up for today? Lauren, yep.
So just for the last example, like in the originally it was x is the positive integers.
Oh, sorry. It works also for the integers, but yes, I should say the positive integers do not have the same cardinality. It'll work for the integers as well. It's just a slightly more complicated. You'd have to go back and forth with positives and negatives. So it works also, but I was doing an example with positive integers. Yes, thank you for that. Anything else? Other questions? Do you see a little bit of how cool this is? Just a little? All right, I'll trust you. I will send out a reading assignment. I will send out homework from 13.1. Remember, please, that your homework from chapter 12 is due on Wednesday at noon. So if you have any frantic last-minute questions, we can do those at the beginning of class on Wednesday, but otherwise that's due. And proof notebooks are due on Friday. So don't forget about those. Proof notebooks are due on Friday, at noon, just like normal. Friday morning, we'll do review for the chapter 3 test. All right, last call. Melissa, yes.
The chapter 13 homework, when was that going to be due again?
We will make that due on Monday, since the final exam is Monday, and we'll just stick with noon as usual. So Monday at noon. And again, the Monday test is just a regular test. It's not a longer exam. So we'll just log in at 8, like usual class, and then the exam period goes till 9:45, but you won't need that whole exam period. So we don't need to start early like we did last time. We can just start at 8 and go from there. Anything else? Other logistical questions? Okay, I will try to get the reading assignment sent out now before my cryptography class, and I'll see you guys on Wednesday. Let me know if you have questions on the proof notebook or on the rest of the homework. All right, see you Wednesday. Thanks, guys.